Hi everybody and welcome to our flipped instructional recording for today. We're covering 1.03 energy and matter. So as we get started, be sure to take notes during the recording. I am going to hit the hot spots for you as usual. Also remember that you will be adding your notes and the guiding questions to your science notebook. So you want to be sure to update the slide with the lesson number and name at the top. So here we go, jumping into matter and energy. You've defined it a couple of times already. So now we're taking a look at, again, the definition, physical science, the study of the nature of matter and energy and how they interact with each other. So we're going to focus on a simple example, the way objects behave when they hit the ground. So the drop and bounce lab will be coming up a little later. So you'll see a couple references to this. So soaking this in and processing it is important. So drop each ball and observe how it behaves after hitting the ground. Make some observations about the different balls. Okay, so we're looking at a simulation, and your lab for Unit 1 is a simulation as well, meaning there's no actual materials. It's just something you're looking at online. So how are the balls in the lesson similar? A couple of things here. They're all spheres. After dropping them, they bounce and eventually stop. So we are able to interact with them a little bit. So how are they different? We can see that they're different sizes, different colors, some bounced higher. So we'll continue talking about that as we go. But what are some questions that you might think of based on what we're looking at? One thing might be, what are they made out of? What makes some bouncier than others? So we see the tennis ball is obviously much more bouncy. This looks like a rock. It's not very bouncy. Why do some balls continue to bounce longer than others? So we know that this one bounces a couple of times. The 8 ball, really only twice. And then why do the balls bounce highest on their first bounce and then lower heights after? So these are all good questions that we're going to be looking at today. So our lesson goals today, we're applying scientific ideas or principles to design, construct, and or test a design of an object, tool, process, or system. We're also looking at designing a structure to serve a particular function and describe the properties of different types of materials. The key words that you should have in your notes, if you don't already, would be matter and energy. Again, you have your science notebook template. So hopefully you've already opened this file. It is already saved to your computer. And this would be your third file that you've added, your third slide, I'm sorry. So you have a slide for 1.01. And if you want to duplicate a couple of these, then you'll have them as you go. But so today you would be on the third one. So you have a 1.01, 1.02, 1.03. So you'd want to make sure you edit this information. And from there, you're able to add notes here, or you can come back and add notes in a little bit. But make sure you're doing that for each lesson. All right, so the guiding questions, these are the the questions that go on the left side of the slide. How do different materials behave when they are dropped? How are drop height and bounce height related? So the drop height would be where our hand releases the ball. The bounce height is how high it bounces after it hits the ground and comes back up. And what makes something bouncy and what is elasticity? So these are the questions you'll be answering in the lesson. All right, so as we move on to the next part of the lesson, we're talking more about matter and energy. So as you may have observed in the simulation, when you dropped the balls, some bounced while others did not. Eventually, the balls stopped bouncing and rested on the ground again. Some did this more quickly than others. We will continue to explore the concept of bounciness and the relationship between matter and energy in this lesson. So drop height versus bounce height. I just explained this, so take note here. This answers one of your questions. Use the simulation to explore the relationship between drop height and bounce height. Okay, so if we scroll down, we can see we have a little ball here. Does the ball ever bounce higher than the release height? Okay, so if we pull it up to 90 and release it, no, it does not. Okay, what about this? How can you get the ball to bounce the highest? So if we release it from a higher point, it's going to bounce up higher. So releasing it from the highest possible point, how can you make the ball bounce the lowest? So this would be barely raising it and dropping it, then it's not going to bounce very high. And then finally, what general statement can you make about your observations? So we're able to say something about the release height of the ball determines the maximum bounce height of the ball. So height and energy. When you raise the ball off the ground, you're giving it potential energy. When you release the ball, the energy is turned into motion. Okay, and we will learn a little more about what that energy of motion is called. Some of you may already know that's kinetic energy. So consider dropping a ball from the top of the Empire State Building, which is 1,250 feet tall. How would the energy of that ball when it hits the ground compare to the energy of a ball released 1 inch above the ground? So we know that the higher we raise that ball up, the more bounce it's going to have, which means it has more energy than if it's dropped at a lower height. And so how does this relate to our observations about bounce height and release point? So we know that objects dropped from greater heights can bounce higher because they start with more energy. So why do they stop bouncing? The perfect bouncy ball would continue bouncing to the same height from which it was dropped forever. So what causes bouncy balls to come to a rest in the real world? Some energy is absorbed by the ball with each bounce. This heats up the ball, okay, not in a way that we can feel it, but while we can't see this change in energy, the energy is going somewhere. What makes something bouncy? Some balls are not as bouncy as others. Take a look at the slow motion video of a bouncing ball and make some observations about what happens to the shape of the ball as it collides with the ground. Okay, so there we saw it kind of squished down a little bit, flattened out on the bottom. It compresses. Another thing is it returns to its original shape after compressing. What makes something not bouncy? So observe this ball. Okay, we really did not see a change in shape there. If we compare it, this one does not compress like the bouncy ball, but it also didn't bounce up as high as the other ball either. So the material of a ball affects its bounciness. Materials that are elastic are bouncy. Elasticity is the ability of an object to return to its original shape after being stretched or compressed. Objects that compress and return to their original shape very quickly are bouncy. Other objects, like pillows, might compress and return to their original shape, but they take longer to do so. This makes them not as bouncy. Materials like clay that compress but do not expand are not bouncy either. Rigid materials that do not compress are not bouncy and sometimes break when they're dropped, like this glass plate. So no elasticity there. All right, so maybe make some notes on a couple of things about elasticity, and you also want that definition on the left side of your notes as well. So the amount of air inside a hollow ball affects its bounciness. So you've probably tried to play basketball before with a deflated ball. It doesn't work very well. The air inside the ball compresses and expands when the ball hits the ground. If there's not enough air in the ball won't bounce. The elasticity of a ball is important in sports. Would you use a tennis ball to knock over bowling pins in bowling? Probably not. Or would you use a bowling ball in a tennis match? Not a good idea either, right? The elasticity, size, and mass of the ball are other important properties that you must consider when you play a sport. So apply what you've learned about matter and energy to design a ramp course for each ball that can knock down the block tower. Each ball bounces a bit differently, and there are lots of ways to set up the ramps. So this is a fun activity that you can do. It's like a game, but you're also learning. And so you have some different things you can do here. You've got these objects kind of in the way. They're movable. You can see the ball falls over there, and then it'll reset. I mean the ball, sorry, looking over at the side, those are the blocks that we're knocking over. So if you use a little arrow key, it'll go back, but you could drop these shapes down, right, to make some kind of difference here. And you can drop a ball from the top and see if it's going to get over there. Probably would be a better idea to put something in every spot. So this one looks like it's going to keep it going. And then this one here. Let's see what happens. We'll use the yellow ball, release. It didn't really even do anything. It seems like this ball's very heavy, right? So let's try it again with the blue one. This ball just goes when it's dropped. Seems like it is kind of heavy too. It's getting stuck right here. What about the red? Same deal. So our ramp idea here is not very good. It looks like you could play around with it, try something else out. You can reset it all. So then you'll be able to make some observations there. So how can you knock down the block tower? You could answer that question. All right, so we're at the end of the lesson. Let's take a look at the lesson review. So a couple of these are your guiding question answers. So in this lesson, you learned about matter and energy. You explored the relationship between the drop height and the bounce height and completed a design challenge. Answer the following questions to check your understanding of matter and energy related to bouncing balls. Why do balls eventually stop bouncing? We learned that energy is absorbed by the ball during each bounce. Why do some balls not bounce? We learned that some balls do not compress or expand like a bouncy ball does. And what property affects the bounciness of a ball? So a property is like a description of something, like maybe what it's made of, or something, a detail about it. And we learned that elasticity is a property that affects if the ball is going to bounce or not. Okay, so as you wrap up, make sure you've taken notes or maybe added some pictures, drawings, anything you want over on the left side. And then on the right side of your slide, you've included your guiding questions and answers. So from there, check out your schedule next week or whenever later this week maybe, for your flip follow-up session in science. And then be sure to attend Help Lab if you have any additional questions or need help. And remember to have fun. Have a great day.